Now in this section, we're going to talk about Microsoft's serverless options. Now the serverless options include things such as the Service Fabric, Azure Functions, and Logic apps, and of course there's database, serverless database options as well. But before we get too deep into that, let's just break down the various computing options and where they fit within the overall Azure map. If we go into the marketplace and we look at the Compute tab, we can see the first three things that are being offered to us are what is called infrastructure as a service. So we can fire up a Windows server, a Red Hat Linux server, Ubuntu server, or other types of Linux options. And then we're going to basically have full control over those machines. In the case of a Windows machine, we'll have RDP access. In case of Linux machines, we'll have SSH access. And once we get into those machines, we can basically use them for whatever we want. We can install any type of code that the machine supports. If the machine doesn't natively support it, we can install all of the framework items that are required in order to get that to install it. So if you choose a Ruby application, you might need to install the Ruby code in order for your Ruby scripts to be run, etc. But you would have full control of those servers in order to do that. Not only do you have control of the servers, but they are part of your virtual network. You can put firewall settings either inside of Azure or inside the virtual machine. You can open ports. Basically, just as if you would have a virtual machine running in your on-premises environment, you have almost full control over that machine within Azure. What that means, though, is you also have the responsibility. So if you are to install a Windows server and then you are to open up all of the ports and do some fairly risky things, then it could come back that your machine gets hacked, and it would be entirely your fault because you were irresponsible with that. So with great power comes a great responsibility, as they say. So the infrastructure as a service option is the most powerful, gives you the most control, but also comes with the highest level of responsibility on your shoulders in terms of keeping your environment secure and keeping your code up to date and making sure all the apps that you've installed, when the security patches are out there, you go back and then you install the security patches, etc. It's a full-on responsibility in terms of you protecting these machines from the operating system level up. Now, Microsoft is going to protect their environment. They're going to, again, there's a basic level of denial of service, attack protection, there's, etc. Some infrastructure options. You're not going to have those issues of your physical machines being compromised when Microsoft's in control of that. But you do have a responsibility for the virtual machines, essentially. So that's the infrastructure option. Now, if we go over to the web marketplace, we can see the next level up, which is platform as a service. This is the web apps and the app services within Azure. This counts a web app, API app. There is a function that also runs as platform as a service. So when you create a function, you can choose for it to be serverless, or you can choose for it to run within an app service environment, which is the platform as a service. So I should say at this point there is no effective difference between a web app, an API app, and a mobile app. Years ago, you could have said that one allows you to do something and one doesn't, but all three types of apps historically are now called web apps. Okay. Now this is the web apps are basically allow you to upload your code. You have to do a packaging operation, upload your code. There's a configuration that you either have to include or do within your web app manually within the portal. Basically, it's very much like just giving your code to Microsoft, letting them run it within the context of what you've chosen as your plan. And then you can set various settings, just like in IIS. You go into IIS and you can basically choose what to enable. Do you allow PHP? Do you allow Java, etc.? Okay, so it's just like basically IIS running in the cloud. Now you'll notice other vendors have web app options. So WordPress has one, Sitecore has one, Drupal, and Joomla. So you can basically get this as a platform as a service offering within Azure. So Microsoft's not the only vendor of platform as a service offerings, but you will not find non-Microsoft options on the test. So if you're studying purely for the test, you just need to know that Platform as a Service are all of the app services plus a type of function app. Function app is the hybrid that can be both serverless or web app. We should also talk about containers. Now, containers are growing. In the last couple of years, Microsoft's adding a lot more options. You've got your Kubernetes service, the full-on AKS that you can basically fire up a orchestrator and a bunch of nodes and call it a Kubernetes cluster. You can have a managed cluster, or you can manage it yourself. We also have container instances, which are sort of the quickest way to get containers running. You just it's like a web app for containers. You've got other options on the marketplace, so DCOS is Mesosphere, and Docker options, etc. Okay, so containers are growing. They're types of platforms as a service, right? Because you're just basically you're firing up a container and then you're putting code. But when you're creating a Kubernetes cluster, then you have you're basically in pretty tight control of those servers, how many got created, whether you want to turn one on, turn one off, etc. So there is a level of control when you're creating clusters. So finally, let's talk about serverless as the final option. Now, we already said that functions do count as serverless if you configure them as serverless. The other types of things are logic apps and service fabric. So if I go, let's see, if I can just go back to everything, but okay, I'll go to everything. So if we load up a function app, we can see Microsoft puts that in the web category, but I'm going to go and create a function app to demonstrate. Give the app a name, so call it new function app. Now you can see that this name is universal because it is fully qualified.azurewebsites.net. So I'm going to put my signature first 5 letters. You would choose your own first 5 letters, of course. Now when we get down to the hosting plan, this is what makes it either serverless, which is the consumption plan, or a web app, which falls into an app service plan. So the choice of consumption or app service plan is the determining factor between whether something is serverless or a platform as a service. Why don't we go in the next video and create ourselves a function? So let's create our first serverless app, and we're going to use the function app to do this. So I'm going to say create. Now, as we saw in the last video, you have to give the app a unique name. I'm going to call it AZSJD new function. Again, I use the AZSJD as my unique beginning. That way I never get into any kind of conflicts with other users. So the URL of this is going to end up being this word plus.azurewebsites.net. Now you can assign your own custom domain. We're not going to cover that in this video, but basically you can create your own custom domain and have that domain be the domain that responds for functions. We're going to use my existing subscription. I'm also going to create this in a new resource group. Again, resource groups makes it easy to not only track costs, but also to clean up resources once you're done using them. We have the choice between a Windows operating system and Linux. So even though this is a serverless option and we don't have direct access to the underlying operating system, using Windows versus Linux is going to give us different options for languages that are supported. But we're going to leave it as a Windows option. Now we said this serverless, what makes something serverless is that you're basically paying for consumption as opposed to having a service plan. So the service plan is basically the traditional web app model, the application platform as a service. In the app service plan model, you're basically going to choose a server size. It's going to have different features if you're basically on the free plan or the paid plan, basic and advanced, etc. On the consumption model, we have it's a different pricing entirely. So I'm going to pull in the pricing screen here, and we can see that it's a combination of the amount of CPU time, which is called execution time, and the quantity of executions. Every Azure function top level function has a free limit. So as long as you're less than 400,000 gigabyte seconds in terms of CPU time and under 1 million executions both, then it's not going to cost you anything to have Azure Functions. This is what makes Azure Functions really good for code that is not frequently run, because then you end up being under the free level and basically not having to pay for it. So you can have code in the cloud that doesn't cost you anything. Above the free level of 400,000 gigabyte seconds and 1 million executions, you're going to basically be paying a fraction of a cent, basically 1,000th of a cent per gigabyte second, and 20 cents per million executions. So basically you can do some analysis over how frequently your code's going to run and how much CPU time it takes. Okay, let's go back to this. So we'll run this on the consumption plan. We're going to run this in Central US. We said that the operating system that you choose does determine your options. So we can run this in the .NET stack, a JavaScript stack, or it does support a Java option. If we switch over to the Linux, we have the choice between a .NET stack and JavaScript stack. So we don't have the Java preview, and we can obviously have a Docker container as our function, okay, as a Linux. So we'll go back to Windows, consumption plan, .NET stack. Let's change that to JavaScript stack. And basically functions need a storage account to operate in. So once you've created functions, there is a UI within Azure in which you create the code and you can test the code, but that code needs to be stored. It's going to be stored in a storage account. You're also going to be able to have logs and other things that are stored. So the storage account is going to need to be created or reused. I recommend creating a new one for your functions. We can turn on application insights again. Remember, we haven't dived into that in this course yet, but application insights is a way for the code to surface problems that are happening inside the code to Azure top level. And there's an application insights dashboard view that you can actually go in and you can see how events are happening within your code. And if you're going to use application insights, it needs to be created into a location. So I'm going to turn that off. So we're going to create this brand new function running on JavaScript on the consumption plan, which is a serverless model. And when we come back, we're going to look inside what we've created. All right, so our function deployment succeeded. You can see here that it took only 1.5 minutes to create this function. If we go back, we can see that we have the function itself, and there was an app service plan created for this. Now this can be a bit surprising. We chose the consumption plan. We did not choose an app service plan. But if we go into the app service plan, we can see that it says that it's a consumption pricing model, and we do not have access to scale up, scale out, or to control the networking of this or anything like that. So this is an app service plan, but really we don't have any control over it. So if we go back to the resource group, we can go into the function. Now the function has been created, and if we go into functions, we can see that there actually is nothing been created inside of the function yet. So the function in this instance is just a container. And then we can create one or more functions inside of this container. Okay? And again, we've set this URL as azsjd new function at azurewebsites.net. So any function that we create inside of this container is going to be coming off of that URL. Okay? So let's create our first function. Okay. So I'm going to click the plus sign here. Now, functions, one of the great things about them is that there's a wizard type interface for you to create functions. Okay, so you can basically create a function using Visual Studio Code. You can create the function using a notepad or some type of text editor and then deploy it into this function. Or we can use a portal interface to create and modify our functions. So I'm going to choose the portal interface. Microsoft provides a number of templates. Now, the most popular ones are basically webhook, which means that someone external can call this URL that we're going to create, and that will be the trigger that will cause the function to run. Or we can create a function that runs on a timer, like every hour, every 30 minutes, every day, etc. Then there are other templates. So let's go and see the more templates. Okay. Now, again, we're in the quick start model here. There's also, of course, we can create a blank function and then start to create our own triggers and connect with various components ourselves. But we can see that basically Microsoft's providing a number of predefined templates. We have the webhook, we have the timer. We can also have it triggered off of an entry into the Azure queue. We can have it triggered off of a service bus queue. We can have it triggered off a topic or a Blob storage account. So if a new file gets added to a Blob storage account, that causes the function to run. A database entry, when an email has been added into a SendGrid queue, IoT hub. So there are a number of things that can happen that will trigger a function. Let's create the HTTP trigger. Give it a name called new function 1. And basically we need to know whether the function can be run anonymously, which means there's no authentication required, whether we're going to create function level keys, or whether we need it to have admin level key. So let's leave it as an anonymous function. We don't mind if the outside world calls this function without security. Okay. Now, when we create this HTTP triggered function, remember we chose this as a JavaScript when we were creating it. We can see here JavaScript code, and the JavaScript code is going to be triggered again off of an HTTP call. And then when the HTTP is called, it's going to look at the request, either the query string, or in case of a post, it's going to look into the body of the request, get a parameter called name, and then it's going to say hello name. So if I was to test this, I'm going to open up the test interface, and that means I have to scroll over a little bit here. You'll see here that it's providing me a post request by default, and I can pass in the name of Azure. I'm going to change this to Scott, and that's where the output will go. So if I said, scroll down here, run, it's basically executed. It passed in this parameter of name Scott, and the code inside the function ran saying hello Scott. Okay, let's close out this test. Oops. Go into our function here. Now, what if we wanted to test this another way, right? So let's go into the integration section. Remember, we said that the trigger is based off an HTTP, and then the output is going to be HTTP as well. Okay. We have it enabled, and even though there are keys are not required because this is a anonymous function. Remember, we created it as anonymous function. So let's go to get function URL, and I'm going to copy this URL. Okay. Then I'm going to put my browser in here, and we're going to say, remember we had name equals, and I'm going to say YOU as the name. Okay. The response comes back that says hello you. So we have a function that is accessible over a URL. It's the base URL for the function app /API / the function name, and then we're able to pass in parameters either as a query string or as a post request. Now all of this is based on the code. So if we close this up, we go back here, we can see that this default code that came with it has this hello and the name as part of it. If we didn't pass the name, it would give us a 400 error and say please pass a name onto the query string or in the request body. So if we switch back to this and we were to remove the name, we're expecting the error. Please pass a name into the query string. So you can see the function starting to take shape here. This is the default code, but we can then start to write our own code. What do we want to happen when the function executes? Now, typically just having it interpret the request parameters and then spit back hello or spit back, like if it was a calculator function and it took in two numbers and it did the mathematical addition onto them and then returned the result, that's not entirely useful, right? Having a function that is self-contained, can do its work and then return the result, it has some usefulness to it, but it's not usually entirely useful. So the great power of functions is by having it basically be able to integrate with other parts of Azure. So even though the function is triggered by an HTTP request, we can basically have it go to a storage account, go to a queue. Let's look at the integration options. Blob storage, table storage, an Excel table, Cosmos DB, OneDrive. And these are the sort of the integrations that we can have on input. And what that means is even though the HTTP request came in, we can have it go to a Blob storage account and read a file that is contained within Blob storage. So that is even though the trigger is on HTTP, we can basically have it do something to get some information. When we go to the output side of things, again, we can have it do something other than return a result. So in terms of the output, we can have it insert a record into a queue, save a file into Blob storage, insert a record into the service bus, send an email, send an SMS with Twilio, save a file into OneDrive, send an email with Outlook, right? Do a database entry with Cosmos DB. So there are a number of, these are the built-in options, by the way. So this is basically the templated options. So I'm going to choose Blob storage. Okay, scroll down, and I'm going to say select. Now it says this integration requires the following extensions. So we need to install this extension into our function in order for this trigger, or in order for this Blob storage account to be accessible within the function. So I'm going to say install. Again, it's happening in the background. Now remember, we have a storage account attached to this, so some of this is going to be updating the configuration file, etc. The output blob is going to be called output blob. So if I'm going to create a new output blob, this is what I'm going to refer to it as. It's going to put this into a container with a random GUI ID as its name. There is a storage account connection, so this is a pre-existing storage account connection. I can create a new storage account and a new connection if I wanted this to go into a different place. Let's say save on that. Okay, so if we go back to our function, we have our JavaScript here. Then this means that we can start acting on our output blob. We have output blob as an accessible property, and then we can basically say create our output blob with the following contents. So we've got our output blob that was the output binding. If we go back into the integration tab, we can see that under outputs, we have an Azure Blob storage output, and the blob is named output blob. So output blob is accessed using context.binding, so output blob. And let's just say we're going to put the hello Scott into that output blob. So whenever you call this, let's go back into the test, and I'm going to scroll over here. It says hello. I'm going to change this to Bob. Let's go down and run it. Scrolling back, we can see that the console shows that it ran, executed. The output says hello Bob. But did the blob that get created, the output blob? So let's go into back into the function. Let's go into the storage account. Let's go into blobs. Now we have this out container that was part of our setup. And now we have a blob with this timestamp on it. I'm going to select it. And I'm going to download that blob into my local machine here. And we can see that this blob that I downloaded, I opened it up in a text editor, it says hello Bob. And that is our function that created this blob that sits inside of this storage account. So in this video, we successfully not only created a function, a JavaScript function, we actually tied it to a blob account, a storage account, and basically we're able to write to that storage account and get that function to do some storage within Azure. So in this lesson, we're going to talk about logic apps. Where functions are small pieces of code that you execute in the cloud, logic apps are more like workflows that can tie those pieces of code together. So you can take a number of functions and chain them together using a logic app. Logic apps also integrate with many other Azure services and even external services so that you can have one step lead into another with logic and evaluation along the way. Let's demonstrate that. We have to give the logic app a name. Now, logic apps don't natively have a URL, so you'll see that this name just has to be unique within the resource group. We're going to use the existing subscription. I'm going to put this logic app into its own resource group. You can choose an existing resource group if you wish. Logic apps, just like any service, need to be put into a region. And so I'm going to put that into the central region. Now, if I want to expose the logs of this logic app into Log Analytics, which is Azure's universal logging and analysis platform, I can do that, but I'm going to leave that off for now. That's as simple as it is. You give it a name and a location, and then you click Create. Now, this empty logic app only took around 8 seconds to create, so creating a logic app is fairly quick. We can go into the logic app that we created. Now, because it's empty, it's taken us directly into the logic app's designer. So this is sort of the first view that we have of creating applications inside our logic apps container. In the next lesson, we're going to start by creating a simple logic app. So when you go into your logic app for the first time, you're brought directly into the logic app's designer. This isn't the normal view when you actually do have a logic app, but you're going to be starting off on this kind of screen. There is a video you can watch if you want, but in this case, we're going to scroll down. Now we're given a selection of what's called common triggers. A trigger is an action, an event that happens that causes the logic app to run. So all logic apps need one trigger that's going to cause it to kick off, just like a function really. We can see an example of the common triggers that include the usual suspects like recurrence, which is a time-based, or a message in a service bus queue, an event grid. But now we also have third-party services like Twitter and Dropbox and things like that, which we can create for triggers. Let's go down. We can see that there's a number of templates, and we can choose based on category if we want social media templates and things like that, Slack and tweets and Instagram and MailChimp. But let's create a blank logic app, and that'll show us exactly all the options that we have. So a blank logic app, we're still in the designer here. Now we have to choose a trigger. So what is going to cause this logic app to fire? If I go down here, we can see that there are just dozens and dozens of triggers. Some really interesting external companies like GoToWebinar, GitHub, and HipChat, Infusionsoft, and stuff like that. So this is a really flexible interface. It actually reminds me of Zapier or IFTTT, if this then that. So it allows you to connect many of these services into functions and other applications within Azure. Let's do an HTTP request, sort of the simplest one. So when an HTTP request is received, we want to do something. Now, the URL is going to be generated once we hit save. I'm going to open the advanced options. I'm going to say that this is a GET request that's going to come in, and we could give it a path. And this path is basically going to allow us to define like a REST API. So we can say /API or just API / customer ID. Okay, in curly braces. And so in this format, I've just defined a parameter for this URL. So whatever the URL is that's going to get generated, it's going to have /API and / some type of number that's going to come in, and that's going to be our trigger for this logic app. Okay, I'm going to click the bar to minimize this, and now we have to choose a step. Okay, now we can choose an interesting step, not just directly connect it with other services like Dropbox or MailChimp, but we could actually put some type of if statement in the middle. So we can see there's a condition, we can do looping or a switch statement. I'm going to choose the condition. Now our condition, in this case, I want to check the customer ID. So when I click on this value, I'm given a number of options, but the customer ID that I added as a parameter is a path parameter, as an option in the dynamic options. I want to say if customer ID is equal to 1, then I'm going to do something. I'm going to go into the true statement. You see that we've got a branching condition here, true and false for this condition. I'm going to connect to Dropbox. Now I already have my Dropbox connected, but if you don't, it will ask you to log into Dropbox and give Microsoft Azure permissions. And we're going to create a file. If the customer ID is 1, I'm going to go into my my Dropbox here, Dropbox, oops, go into the arrow. I'm going to go into, these are the folders of my Dropbox. I'm going to go into course stuff, and we have to give it a name. This customer ID can actually be used as part of the name. So I can say customer ID dot txt. Okay. Now what's the contents of the file? The contents of the file could be, again, anything that's passed in from the web URL. So let's say there's a body, a schema for the body where we upload data into more of a post request. But this is a GET request. Let's just leave it as this is customer number, and then I'm going to put the customer ID into the body of the file. Okay. Again, this is a bit of an arbitrary thing that we're creating here. So this is going to create a file in my Dropbox in the core stuff directory with the customer ID.txt, where this is customer number 1. Now if it's false, perhaps I don't want to create the Dropbox file. Perhaps I just want to, let's look for the response. Look for the response action, and we're going to say that the status code is 400, and we're going to say, sorry, we're not interested. Okay. And in this case, I can put the response code 200 and say, yes, awesome, you are great. Right, so we're doing different options based on the value of the customer ID being passed. So you can see that you can start to create some fairly elaborate logic apps, which are basically got looping and if-then statements, connect to outside services, connect to inside services, SQL servers, SQL databases, blobs, and sort of you can create basic programming in here. Another thing that can happen, of course, is with functions. One of the popular things that we can do is to connect our logic app into a function that we created. Okay, so Azure Functions is an action that we can choose within logic apps. We can choose one of our functions. Okay, we can see either create. This is the one. So we can basically execute a function if we have them as part of our logic app, and that's a very popular thing to do. And I'm going to leave that for now. So let's save this. Okay. As a reminder, we are calling an API. Here's the URL, and we're expecting /API/customer ID. And if that customer ID ends up being the number 1, then we're going to create a Dropbox file. Otherwise, we're going to return an error. Okay. So I can actually go into my browser here. I'm going to paste in the URL. You can see that it's got the spot for the customer ID. Let's put the number 222 in there and hit enter. And you see that the number 222 resulted in sorry, we're not interested. Exactly what we expected. If I change the 222 to a 1, then it returns a yes, awesome, you are great. And if I go into my Dropbox, I can see 1.txt was created, and the file that I opened says this is customer number 1. So our logic app basically allows us to do some more sophisticated programming in a serverless fashion. Notice that we're not actually developing in Visual Studio. We're not uploading code. We're actually using code that's embedded within the browser within Microsoft Azure. There's some visual elements in terms of the Logic App Designer here, where we can sort of see how apps get created. If we wanted to switch over and look at the JSON file, if we're more comfortable looking at a more sophisticated things, we can see the JSON file, and perhaps we can even modify. No, I don't want it to say 400. I want it to say 401, and that would basically allow us to modify the Logic App in code as well as within design. So Logic Apps can be fairly sophisticated workflows, similar to the Windows Workflows service. So yeah, Logic Apps are really useful things within the serverless environment. So the next serverless technology that we're going to talk about is called Microsoft Event Grid. Now, Event Grid is another one of these event-driven serverless applications that basically listen for any one of a number of events and then pass that information on to a number of listeners or handlers. So it's basically purely a glue between events that happen and types of programs that can handle those events. So we see here this diagram, sort of the classic event grid diagram, that we can detect events that happen within blob storage, media events. I'm going to skip to event hubs, IoT hubs, service bus queues, and we can even create our own custom events. So if you've got applications that can then fire off events, then those events get detected by event queue and passed on to other things. Now you might wonder, well, functions can detect blob storage changes and logic apps can detect blob storage changes, so why do we need a event grid? Well, in that particular case, maybe you don't need the event grid. But if you do not need a logic app, you might want to connect a blob storage directly into a queue with no logic app or function in between. Then you can use an event grid to take the event that occurred and create a new message in a queue relating to it, right? So let's put this aside and go into the Azure portal. Now, before we can work with events, then we need to make sure our subscription can handle it. So we go into subscriptions here, choose our pay-as-you-go subscription. In my case, your case might be different. And we want to go down to resource providers. Now we want to make sure that the event grid resource provider is registered. In this case, it is. So we should be able to use event grid on this account. Okay. Now to create an event grid, so let's go into these three dots here that says all services, and we're going to put the word event grid. Now we have the options between topics and subscriptions. Let's go into the subscriptions view. Now right now we don't have any event subscriptions, so we're going to create one. Now we're going to be taken into the basic editor. There is, of course, an advanced editor which is code-based and as well as some additional features. What are we going to be listening for? Well, remember, we had that diagram that basically shows us the types of topics that we can subscribe to. So we're going to go and we're going to choose the resource groups. Okay, so really we want events that relate to resource groups. It says choose the subscription, and I'm going to choose my subscription. Now, which resource group do we want to listen to? Let's go into the Logic App resource group that we created for the last video. Now, what events do we want to be notified? Right now, by default, it asks to notify us for all events. Now, that's actually something that we would be interested in, but let's uncheck that. And then we can see the types of events that we can listen to for a resource group. We've got 9 events, 3 for writing, 3 for deleting, and 3 for any type of action. So let's say we want to be notified when somebody tries to delete a resource. That's our event grid action here. So it could be success or failure, or the deletion got canceled before it could succeed or failed. I want to be notified of any of these. Now the next question is, where do we want this event to go to? So let's bring this diagram back. We see that we can basically trigger a function, trigger a logic app, some type of batch automation, any URL based, so we can call it just a URL even if it's not hosted within Azure, add a message to a queue, go across the hybrid subscription and get into our internal environment, or even trigger an event in an event hub. So in this case, let's call the logic app. So even though we're creating this in the logic app, let's go into here, and we want to use a webhook, and it's going to ask us to enter the endpoint. Now remember, we were playing with that logic app, and so I'm going to paste the URL of the logic app into here. So I pasted the logic app that we just created. Now I know the logic app we created doesn't actually do anything to process deleted resources, but for the sake of this demonstration, let's say we wanted to call that URL, and let's pretend that our logic app actually could act upon it, send me an email, send me an SMS message, etc. Okay, so we're going to say that's okay. Now, basically, we've got our source for the event. We've chosen which types of events we want, and we know who's going to handle the event. Okay, we give it a name, so let's call this the monitor deleted resources event, and letters, numbers, and dashes. Okay, so we have to not have spaces in it. And the schema, there are only 2 types of schemas. That is the Microsoft standard, which is like a proprietary standard that contains, this is the format of the data that comes in from the event, or there's an open source cloud event schema, which is basically an open source type of event schema. Let's choose the event grid schema, unless we have a reason to use the open source one, and click create. So now it's basically subscribing us to the event. When anytime in this resource group an event gets created, gets deleted, we should call the logic app with that. Now I have to go into resource group search, and we can see that the monitor deleted resources is running, and it will call our logic app whenever we delete something within this resource. Now I know that's a simple example, but again, the event grid is meant to connect things like this, any type of subscription, resource group, event that happens, to some other thing. So it's basically just connector between 2 event creator and an event handler. So in this lesson, we're going to be talking about the Azure Service Bus. Now the Service Bus is sort of an all-encompassing platform. Microsoft calls it Messaging as a Service, or MAAS. You can see the logo has a little envelope symbol. And so that represents the ability for applications to send messages to each other. The most popular or famous Service Bus service is called the Service Bus queue, and that allows one application to put a message into the queue and another application to read that message, or for applications to subscribe to a topic and basically have a one-to-many type of communication platform. Service Bus also allows you to have hybrid communication. So you can have services running inside your firewall in your on-premises network and using the relay service. Applications that are running outside your firewall can connect to the Service Bus relay and pass messages inside your firewall. So let's imagine you have an API inside your firewall protected by security, but you need to access that API from outside. You can set up a relay that will allow that communication to occur without having to modify your firewall. The messaging operation, basically similar to events, actually allows you to decouple your applications. So having one application able to send a message to another application is a way of designing your applications to be independent and not having such tight coupling, which could make it harder to test, harder to deploy, etc. The alternative, of course, is the event method where your applications fire off events. You can have a custom event in an event grid that passes that on to something else. So this is the messaging metaphor. Let's create our first Service Bus namespace. Now you can see that the URL is fully qualified. It's got .servicebus.windows.net. So the name that I give it has to be unique across Azure. I'm going to call it AZSJD new service, and that'll be .servicebus.windows.net. Now we need to select a pricing tier. There are 3 pricing tiers currently: Basic, Standard, and Premium. Now the Premium tier, obviously Microsoft is what recommends for production workload. That comes to almost $900 a month, over $800 a month for this type of messaging system. But what you get for that is a dedicated capacity so that basically all of your messaging operations operate under dedicated CPU and other resources. You get 1 megabyte of messaging size at that premium level, both the queues and topics. Now topics are the one-to-many communication, where queues are one-to-one communication. And you do not have a limit to your messages per month. And again, that is capped out at a fixed pricing, so you can basically know what to expect. Now, I'm going to choose the Basic. Basic only allows queues, and it runs at about 6 cents Canadian per million messages per month, which is super cheap, right? As long as you're in a testing capacity, right? So we're going to create a basic pricing tier for this demonstration. Goes on my subscription pay-as-you-go. I'm going to put that into my Logic app resource group because that'll make it easy to clean it up at the end of this. And I'm going to choose the Central US region, just like I usually do. And we're going to say Create. Alright, so we have our Service Bus namespace. Let's go into it. I'm going to minimize this so we get maximum screen real estate. So we can see, much like many of the Azure services, we have an overview screen here, and there's some pretty graphs that'll tell us how many requests, how many messages are passing through. You can imagine in a production environment where applications are using this all the time to pass messages back and forth between each other, then you're going to want to know how crazy it is, whether the resources are going to be enough, etc. Okay, so this is a basic queue. We don't have topics that we can create. The one-to-many conversations can't happen under this basic queue, but we can create a basic level queue, and I'm going to call this sort of test queue. The queue can have its size. We can have a maximum age for a message, the maximum time that a message is allowed to stay in the queue. I'm going to say 2 days. The lock duration. So a lock is basically when an application pulls a message, then that message is locked so that other applications can't pull the same message. The application has 30 seconds in this setup to confirm that it's read the message and acted on the message. We can make that lock something like 2 minutes, and that gives it plenty of time to do its work and then confirm that it's acted on the message and the message can be deleted. You'll see some interesting settings here like duplicate detection, so that the same message does not get inserted into the queue twice. Dead lettering, basically. So if we have a message that never gets successfully delivered to any receiver, then it goes into a dead letter queue. And those are basically messages that could not be successfully processed. And we're going to hit create so we can get this queue. So give that a chance to run. So our queue is successfully created. We can go into it here, and we can see here, I'm going to open the essentials, that it has a URL. We created the service has a namespace, which is fully qualified, and the queue is that namespace / the queue name. This is the URL we would use in our programs and applications in order to insert messages into the queue and basically be able to read messages from the queue. So that's basically how we create a service bus queue. It does support other security settings like a shared access policy where we can set up basically policies for other applications to be able to read and write to this queue. It's got scaling options to go to a standard tier if we wanted to, the ability to do disaster recovery on the premium level, etc. So the Service Bus overall is a messaging platform. It supports queues, it supports the relay service, etc.